All right, happy Friday, guys. This is Systems of Equations Elimination. So, elimination is a method for solving systems by adding or subtracting these equations to eliminate a variable. We call it elimination because we're going to eliminate one of these variables. So the very first thing we have to do is make sure the equations are lined up. You have to make sure you have the y, the equals, the x's, and the constants all lined up. And the biggest thing that they'll try and trick you with is the equal signs. Sometimes the equal signs will be different, but the x's and y's and constants will be the same. So be careful to look out for that. I might make that mistake a little later on. I actually haven't looked over this. But that's okay. So then we will add or subtract the equations to eliminate it. You're going to add or subtract the ones with common coefficients. You're going to solve for the remaining variable and then substitute your answer back in to solve for the other one. So once it gets to about here, this is pretty much the same as substitution. So for number one, the very first thing we're going to do is you see that the coefficients for y is the same. That's a 1. So what I want you guys to do every single time is add. Now, that's going to be a little tricky, but here's how I want you to add. So you notice that these two coefficients are the same sign. So if I add them together, that's not going to cancel them out. That's going to give me 2, right? So what I want you to do is change the signs of all of these. And you can't do it to just one. You have to do it to everything. So you may be telling me, Mr. White, that looks a lot like subtraction. Yes, it does, but I don't want you to get so confused on, oh, is this a 3x minus an x, or is it a 3x plus x, whatever it is, minusing a negative. And I've taught it that way in the past, and kids get confused. So I'd just rather you guys add every single time and just make sure that those coefficients are opposite signs. So you see we are good here because we have a positive 1 and a negative 1. So we're just going to add straight down. So on this side, we're just going to be left with 0 equals 2x, and now that's a positive 2 plus 6. And we're going to solve for x here. So we would subtract 6 and divide by 2, and that gives me a negative 3. So this is a really quick and easy way to get straight to that first answer instead of having to substitute the x minus 2 in. So now we have the x minus 3, and we take that and we can plug it back in. And we need to plug this back into the original equation. So we'll do y equals 3 times a negative 3 plus 4. So that'll be a negative 9 plus 4, which will be a negative 5. So that is your final answer there. X is negative 3 and y is negative 5. All right, for number 2, we'll do the exact same thing here. You notice that the x's have the same coefficient, but they need to be different signs. So I'm going to make this a negative, this a positive, and this a negative. Now we're just going to add straight down. So the x's will cancel out. We will be 4y and 1y will give us 5y, and 13 and negative 3 will give us a 10. We divide that by 5, and y is 2. So we take that 2 and plug it in for either one, but I'm going to always plug it into the one that we did not change, just so that I keep all of my signs the same and not accidentally make a careless error. So I'm going to take that 2 and plug it in for the y right here. X plus 8 equals 13, and x will equal 5. So again, like I said in the previous video, be very careful that you don't put 2, 5, but instead you put 5, 2, because the x has to come first, even though we solve for the y first. All right, so skimming down to number 4. Or better yet, I'll go ahead and do 3 with you, because the next set, we have only one page of notes on this. So the 3x's are the same. We're going to change that so that we have a different sign, and then we're going to add straight down. So the 3x's will cancel out. We have a negative 10y and a positive 9y, which will give me a negative 1y. And we have a 14 plus a negative 15, and that'll give me a negative 1. So y will equal 1. From there, we take that y and plug it into the one that we did not change. 3x minus 10 times 1 equals 14. And then, did I do something wrong here? 3x minus 10? No, we're going to add. That's right. So we're going to add 10, and that will be 24. For some reason, I was thinking subtract 10. And that will be x equals 8. So our final answer there is 8, 1. Lastly, for number 4, we have the y's that are different, or the y's that our coefficients are the same. So we need to change the signs of all of these, and then we will add. So that will be 6x. The y's will cancel out, and we'll be left with a negative 12. 6 and negative 18 gives me negative 12. So we divide by 6, and that'll give me a negative 2. Oh, excuse me. From there, we take that negative 2 and plug it in for the x. So that will be a negative 2 up top. Negative 8 plus 2y equals 6. We're going to add 8. 2y will equal 14, and y will equal 7. So our final answer there is negative 2, 7. Now, what I've done to kind of make this a little easier on you guys is not giving you this whole next sheet, but instead just gave you that first part of homework. And we're going to go to this more practice about what you do when there's no matching coefficients. So if there are no matching coefficients, you multiply one or both equations by the leading coefficient to force matching coefficients. So here's what we'll do. If you notice, for number 1, we do not have matching coefficients like we did before. So what we will do first is multiply the top by the bottom leading coefficient. So that 2 right there is the leading coefficient of the bottom equation. So I'm going to multiply the top by 2. Okay. Then what I'm going to do is I'm going to multiply the bottom by the opposite of the top leading coefficient. In other words, that top leading coefficient is a 1 right there. I'm going to multiply it by a negative 1. Okay, so we need to have one of them be positive and one of them be negative. We're getting this all in one step. So you multiply the top by the bottom coefficient, and you multiply the bottom by the opposite of the top coefficient. So what we will have there when we multiply everything by that 2 right there, we're going to multiply it to every single part. So we're really just doubling everything. So that will be 2x plus 6y equals 12. And then if I multiply something by negative 1, I'm really just changing the sign for all of these, right? So that will give me a negative 2x plus 7y equals positive 1. So now you can forget about what we had, okay? I actually wouldn't mark it out because we're going to plug it back into it later. But now you see that we can just do elimination, and we have those coefficients that are matching but opposite signs. So the x's will cancel out. We'll be left with 13y equals 13, and y will equal 1. So here's the thing. If you plug in y equals 1, you can technically plug it into any one of these equations. The first or second one over here, the third or fourth one over here. It doesn't matter which one you plug it into. I would suggest plugging it into the original one because you're working with smaller numbers and it's going to be a lot easier to work with. So I'm going to plug that 1 in to this first equation. I copy it down, and then I plug in the 1, and that's x plus 3 equals 6, and x will equal 3. So my final answer is 3, 1 for number 1. Okay, so for the next one, number 2, I'm going to multiply, again, the top equation by the bottom leading coefficient. So I'm multiplying that top equation by the 2. Then I multiply the bottom equation by the opposite of the top. Okay, by the opposite of the top. So that will be a negative 9 since the top is a 9. So I'm going to write out my new equations out here. That'll be 18x plus 6y equals 24. and then that will be negative 18x minus 9y equals negative 45. So if you look back at number 1 real quick, I do want to bring your attention to something. Some of you may have been saying, hey, Mr. White, we really only needed to multiply the top one by 2 and then just change all the signs. Well, yes, that is true, but it's not always going to work out like that. And even you could say here in number 2 that, hey, we really only need to multiply the bottom one by 3. I get that, and that's true, but if you do the top and the negative of the bottom every single time, it will work out every single time. Plus, there's going to be some cases on the next page. You won't see any on this page. Granted, you could just, yes, multiply the top by 4, multiply the top by 2, multiply the bottom by 3. I get that, and if you prefer to do that and you still get the right answer, that's fine. But I'm teaching to all of my students, and there are different cases, like take, for instance, number 8 right here, where there's not going to be anything you can multiply to make it nice and neat to get that coefficient to be the same. Now, granted, you don't have number 8 on your notes, but what I'm saying is if you follow these steps every single time, it will work every single time. And it's not that cumbersome. It's not too difficult to do that many extra steps. So, x's cancel out, negative 3y equals negative 21, and y will equal 7. And if you had no clue what I'm saying there, then don't worry about it. Just keep doing what you're doing. So we're going to take that 7 and plug it in here. I'm actually going to use this one because that y is just by itself. 2x plus 7 equals 5. So now I don't have to multiply out anything. I'm just going to subtract that 7 and divide by 2. So our final answer here is negative 1, 7.